Now that we understand intermolecular forces, let's look at some of the properties of solids and liquids that are also affected by intermolecular forces. The first one is called surface tension, and that comes from the idea that molecules in the interior of a liquid have more interactions than molecules on the surface of a liquid. So if we look here, this is a droplet. Molecules on the interior of a liquid are completely surrounded by other molecules, so there are more interactions involving its intermolecular force. A molecule on the surface of a liquid is not completely surrounded by other molecules, so there is a limited amount of interactions that involve its intermolecular force. Overall, that means molecules on the interior of a liquid are more stable than those on the surface. And this idea means that the molecules on the surface would rather be on the interior. So these molecules on the surface are constantly pulling in or trying to be part of the interior. This idea creates surface tension. So overall, this means for a liquid, liquids want to be in a spherical shape because a sphere is actually the geometric shape that has the least surface area for a given volume. So if you look at water, water forms drops or forms almost a perfect circle. The reason why it does that is because a sphere has the least surface area for a given volume. The least surface area means we have the least amount of molecules on the surface, and so this makes it more stable. So the rule is that as the intermolecular forces of a liquid increases, the surface tension also tends to increase. Another property is viscosity, and the idea here is if I have a liquid, there is an intermolecular force going on inside of this liquid. As the intermolecular force increases, then this also creates internal friction, so it's harder for that liquid to move if we increase the intermolecular force. So that's really what we mean by viscosity. It's a measure of how strongly the molecules inside of a liquid are interacting with each other. So here again, as the intermolecular forces of a liquid increase, the viscosity of that liquid tends to increase. We've already seen this one, that for a melting point of a solid, as the intermolecular forces of that solid increases, the melting point tends to increase. So as a solid, the atoms are completely stationary, they're bonded together, and to cause it to melt, we need to cause a slight separation so the solid becomes a liquid. So as a liquid, those molecules inside of the solids need to start moving around. So as the molecules have a stronger interaction, as they have a stronger intermolecular force, it's going to be harder for them to become a liquid. So as the intermolecular force of a molecule increases, the melting point of that molecule tends to also increase.